Now let us look at the next formula from this section, that is section formula. Section means the parts. Yes. So in this formula, in this heading, we have to see that what if a line is provided to you and there is one point on this line which is dividing the line into different sections. So what will be the coordinates of that point? Okay. For that, I have taken one example. I have considered AB to be the line with coordinates A as x1, y1 and coordinates of B as x2, y2. P is a point on AB such that it divides AB in the ratio m is to n. Okay, so P divides AB in ratio m is to n, and we have to find the coordinates of P. Okay, so we have to find the coordinates of P. I have assumed the coordinates of P to be x and y. So you have to find what is the value of x and what is the value of y, right? So if you find out these two values, it means you will be getting the section formula. I have already considered it as a general formula. So then directly deriving this, we will be getting the section formula. For this, let us draw three perpendiculars from B, P and A. Okay, so three perpendiculars I have drawn on the x-axis. Let us join line AQ whereas line PC. Okay, again I am drawing a perpendicular from A on this line. Suppose I name this as MNO. So from A I am drawing a perpendicular on PN, whereas from P I am drawing a perpendicular on BO. Okay, just keep in mind we have to find the values of x and y, because that is what the question is. What will be the coordinates of the point which is dividing the line in a given ratio, right? Now this is also perpendicular, right? So let us see in triangle PAQ and triangle BPC. Are the two triangles similar? Let us see. Triangle PAQ and triangle BPC. Okay, angle Q and angle C both are 90 degree. Okay, so I have got one angle which is equal. Is angle APQ and angle PBC equal? These two angles, are they equal? Yes. Why? Because these two are the perpendiculars. It means they will be parallel to one another, and if these two lines are parallel, these two angles will be equal by corresponding angle axiom. Hence angle APQ is equal to angle PBC, corresponding angle axiom. If two angles are equal of any two triangles, we can write that triangle PAQ is similar to triangle BPC. Yes. Okay. Hence, if the two triangles are similar, their sides will be proportional. So PA upon PB equal to AQ upon PC equal to PQ upon BC. Okay, so now why we are taking this? Because then we will be finding the values of this length and then we will be replacing it, and hence we can find a equation in which x, x1, y1, x2, y2 and m and n are present. Okay, let us find the lengths. What is PA? PA is nothing but this length. What is the value of PA then? M. What is PB? PB is nothing but this length whose value is n. What about AQ? How much is this total length? Whatever is the x coordinate of P. So this total length is what? X. And what is this much length? This is x1. So what will be this remaining length? It will be x minus x1. Right? Similarly here, what will be this total length? Whatever is the x coordinate of B, that is x2. And what is this length? This is x. So this length would be x2 minus x, right? So we have got the value of AQ. We have also got the value of PC. Now we have to find the value of PQ. Again, PQ means this complete length. Sorry, PQ means this much length. What is this complete length? This complete length is y. And how much is this complete length? This length is y coordinate of A, that is y1. So how much will be this length? This will be y minus y1. Similarly, this complete length as y2, this length as y. So this will be y2 minus y. So now we have got the values of all the lengths. Just put it back. PA is my m, PB is my n, AQ is my x minus x1, whereas PC is my x2 minus x. What is my PQ? PQ is my y minus y1, and my BC is my y2 minus y. Okay, so now you have got one relation between the lengths, and from this, can I find the value of x and y? Yes, because I have got the variables x and y present here. Yes, so let us consider the first two equations and find the value of x. M by n is equal to x minus x1 upon x2 minus x. On solving this, we can find the value of x, or we can get an formula. Let us simplify. M into x2 minus mx equal to nx minus nx1. Okay, so take the x terms together and x1 term together. So it will be mx2 plus nx1 equal to mx plus nx. Taking x common, so what we are left with? X in bracket m plus n. Shifting this m plus n to other side, I will be getting, therefore x is equal to mx2 plus nx1 upon m plus n. Okay, so this is the formula for finding the coordinates of a point present on the line which is dividing the line in the ratio m is to n. Similarly, now I will be considering m by n and y minus y1 upon y2 minus y. On simplifying this, you will get the coordinates of y as my2 plus ny1 upon m plus n. So just if you know the coordinates of A as well as the coordinates of B and the ratio in which the line is being divided, you can find the coordinates of the point which divides that line in the respective ratio. Okay, so this is the formula for finding the coordinates of the point. The x1 is mx2 plus nx1 upon m plus n, whereas the y is my2 plus ny1 upon m plus 1. Means m has to be multiplied with the coordinate of the another side, whereas n has to be multiplied with the coordinate of the first point. Okay, similarly with respect to y also, m has to be multiplied with y2 and n has to be multiplied with y1. So this is the section formula for finding the coordinates of x and coordinate of y. Now from this we can find, what if point P is dividing the line in equal ratio? What does that mean? If a point P is dividing the line in the equal ratio, meaning this is also 1 and this is also 1. Equal ratio means what? Dividing it in equal parts. Yes. And when is this possible? P divides the line in equal parts, and it means P is nothing but midpoint of the line. Yes or no? And if P is midpoint of the line, it is dividing the line in the equal parts, so the ratio will be 1:1. So what change will happen in your formula? Now the value of m will be 1, whereas the value of n will also be 1. So just change the values. So x will be what? My 1 into x2 is x2 plus 1 into x1 is x1 divided by 1 plus 1, which gives me x1 plus x2 divided by 2. Similarly, what will be y? y1 plus y2 divided by 2. So this becomes the section formula for finding the coordinates if the point is a midpoint of the line. Whenever the point is midpoint, the ratio in which it divides the line is equal, hence the ratio will be 1:1.